A constellation is born. Introducing Starlink. SpaceX's Starlink is an ambitious project aiming to provide global internet coverage. So, how does it work? Imagine a network of satellites orbiting Earth. These satellites are not stationary. They move across the sky, ensuring coverage for different parts of the world. As one satellite sets, another rises, creating a seamless connection. Starlink is like a well-choreographed dance. The satellites are designed for efficiency. They are relatively small and lightweight, which makes launching them into space more cost-effective. The goal is to have thousands of these satellites in orbit, creating a robust and resilient network. Starlink is already making a difference, providing internet access to remote areas and proving useful in disaster relief efforts. The future of connectivity looks bright, and Starlink is leading the way. Whispers. From space, the language of radio waves. Satellites communicate using radio waves, which travel at the speed of light. Starlink uses specific frequency bands designed for satellite communication, different from the frequencies used by cell phones. The choice of frequency is important as it affects the signal strength and coverage. Higher frequencies offer more bandwidth, meaning they can carry more data, but they are also more susceptible to atmospheric interference. Starlink uses a combination of frequencies to ensure reliable communication in various conditions. The satellites transmit data to ground stations, which then relay the data to users on the ground. It's a complex dance of signals designed for speed. Starlink aims to provide low-latency internet, meaning minimal delay in data transmission, crucial for activities like online gaming and video conferencing. Starlink's technology makes this possible. Earthly ties, ground stations, and their role. Ground stations are essential for Starlink's operation. These stations, located around the world, act as intermediaries between the satellites and users. When you access the internet using Starlink, your data travels through a ground station. Ground stations have large, highly directional antennas that can precisely track and communicate with specific satellites. The antennas receive data from the satellites and transmit data back to them. The location of ground stations is strategically chosen to have a clear line of sight to the satellites, ensuring optimal signal reception. Factors like weather and terrain are also considered to minimize signal interference. Ground stations are connected to the internet backbone, the network of high-capacity cables that carry internet traffic around the world. The data from Starlink satellites is integrated into this network, making it accessible to users globally. Section 4. The future of connection. Laser links and beyond. Starlink is evolving, with SpaceX enhancing the system's capabilities. A key area is laser communication. Imagine satellites equipped with lasers, communicating seamlessly. Laser communication offers faster data transmission and less interference. SpaceX is also increasing the number of satellites in orbit. This provides greater coverage, benefiting remote areas. Starlink's promise. Bridging the digital divide. Starlink can revolutionize internet access, connecting remote corners of the world. This impacts education, healthcare, and economic development. Imagine students in remote villages accessing online resources, or doctors providing telemedicine consultations. Starlink makes these scenarios a reality. It can also be a lifeline during natural disasters. When terrestrial infrastructure is damaged, Starlink provides a vital link, aiding rescue and relief efforts. Starlink is more than just internet service. It's a testament to human ingenuity and our desire to connect globally.